Okay, hello everyone. My name is Bulent. I'm a PhD student in civil engineering and wood science. Today, I'll be presenting on our research project, which is the serviceability performance of the CLT concrete composite floor systems. So the main objective of this study is the evaluating some serviceability key metrics like the creep, vibration, and acoustics. Through our experimental works, we investigated some key variables, like the adding concrete will enhance the stiffness, but the addition mass may have some negative effects for vibration or acoustic. So the first variable is what is the effect of the concrete topping? The second one is the effect of the CLT species. So we know the different CLT species have different mechanical properties, so different stiffness values. It may have some different effects on the serviceability properties. The third one is the type of the shear connectors and the spacings. And the last one, the effect of the span configuration, like the single span and the cantilever span. So we conducted some like the full scale experiments to measure the vibration, acoustic, and creep performances. And we also performed some push out tests to measure the individual connectors' creep performance, because we believe the creep on connector can affect the overall creep performance. We validate our experimental studies with some analytical methods by using the gamma methods or finite element models in Abacus. We also developed some like the knee models by using fiber section approaches. So to start with the acoustic and vibration experiments, we tried 3 different connector types. This is the washer screw, which is installed vertically. And we have 2 different self-tapping screws, which are installed in 45 degrees. We tested all the bare CLT first for acoustic and vibration. Then we installed the connectors. We cast the concrete, and we repeated all the tests in composite form. We had like 7 short specimens and 4 long specimens. We repeated the long specimens tests for acoustic and vibration in cantilever span forms. We tried 2 different CLT species in those experiments, the Douglas fir and the spruce pine fir. So we built some acoustic boxes in here. So these acoustic boxes are built by using the XPS foam boards. They are like 2-inch thicknesses. We measure the acoustic modes of the chambers, the absorption and reverberation properties. We measure the impact sound insulation performance to check the effect of the shear connector type, the CLT species, and the concrete topping. We placed 3 microphones in each acoustic box. And we also used the tapping machine to generate the sound. So you can see the inside of the box, and this is the tapping machine to generate the impact sound. And I just put the results for 1 specimen. This is one of the long specimen, which is about 20 foot in length. So you can see the acoustic, the 3rd octave band frequency analysis results for bare CLT and the composite system. So if you add the concrete, the sound pressure levels decreased about like 15 or 20 decibels. So which means you can improve the sound, the impact sound insulation of these systems by just making the systems composite. I didn't put the results for the other cases, like the effect of the shear connectors, this effect of the spacing. We also built 1 specimen by using no connector. The concrete is floating over the CLT specimens. The next, the vibration performance. This is how our vibration specimens looks like. This is the short specimen, the long one with the cantilever configuration. We use the eccentric mass shaker for excitation source. We used accelerometers. In total, we have 6 accelerometers. And we just did some dynamic analysis. And we also validate our test results with some numerical models, like with gamma method and some abacus results. At the end, we find the natural frequencies, the damping ratios, and the mode shapes. This belongs just one specimen. This is Bayer CLT, and this is the composite specimen. For the Bayer CLT, for example, the fundamental frequency is about 9 hertz. If you add the concrete, this one increased to above 10 hertz. This is how the concrete topping changed the fundamental frequency of those kind of the systems. And we also performed some creep experiments. We did both the individual fastener tests and full size tests. So this picture belongs to like closed space, the environment space for our individual fastener tests. We assessed 3 different connector types again, 2 different CLT types, and we applied 2 different loading levels. So this is how our setup looks like. For each concrete block, we have also a shear connector inside this concrete block. We applied load by using this compression spring. For this one, right now, we are applying about 1,500 pound loads to each block. This one applies like 1,000 pound load. And we have the dial gauges, and we are tracking like the long-term deformation. So I have a year data. The first data belongs to like the July last year, and I just taking the picture for the last data a week ago. It's still ongoing. So I have about like 40,000 images right now. So this is just the creep data. You can see the different trends. I believe this is because of the seasonal effects. We also test the full size specimens. So you can see our experimental setup here. This is a very good way to save some spaces in your lab, because we have like the 10 different specimens. Imagine if you just test like all of them in a single as a single specimen. You need like 10 different concrete blocks. You need lots of spaces. Right now, so this concrete is under the compression. The CLT is under the tension, and this one is upside and down. So this one equals to that one exactly. They are still 4-point bending. With the overall weight, the bottom one is washer screw, which is stiffer screw. So how we stack those specimens by check. So we try to have the same shear demand for the screw. So all those specimens are kind of under the similar loads. And I also have the results for full size creep specimens. This data, the creep data, belongs to the bottom, the composite specimen. I'm using one of the SDS connector, and this is the results of the creep for over a year. It's still ongoing. We have different trends, and we believe, again, it's because of the seasonal effect. I concluded the vibration and the acoustic test. Right now, I'm writing the papers about those two subjects. The creep ones are still ongoing. And we hope we will stop those experiments like in maybe, I don't know, in 2 or 3 months. Then I will start to evaluate those results. Thank you.